motor control system lectures. So motor control is a study that regulates the control or operation of an electric motor. And importantly, motor control switches can provide overload protection and safely start, stop, and also control the speed of an electric motor. And so basically, there are two modes through which motor control components can be started or stopped. It can either be done manually or in an automation state. And so motor control equipment requirements may include the concept of the disconnect means, where a mechanism to safely disconnect the motor and control it from the power supply. It should also have a short circuit protection, because we know that the short circuit is not needed in an operation, and so it should have protection against high current fault conditions. That is going to help us prevent damages to the motor and also the system. And besides so, there are cases where we would experience some overload protection that should be needed, because some overload may occur in a system, and so devices like the thermal overload relays can be used to protect the motor from excessive heating due to overcurrent. Okay, and most importantly, we should have a control means, meaning a switch or a system for starting, stopping, and if necessary, changing also the motor's direction. Okay, then I made mention of a motor starter, but there are certain factors that you need to consider before selecting a motor starter. One, the limitation of starting current, which will cause minimal disturbance to other users in regards to line voltage, because we know that you're not the only one that is going to use power, and so you need to make sure that you do not have disturbances in the line voltage, because there are other users again. And also the second thing is the ability to control the starting and acceleration torque, because speed, in as much as it is desired, you should be able to control it. Okay, then protection of the motor from overheating and overloads, of which the overheating that can be caused due to many factors like single phasing. Okay, maybe there is a loose connection that will at that point be able to demand a lot of current, because a balanced load is expected at the end of the day. But in case there are gears that have been connected to our motor shaft and then it is stuck, it means that it will draw a lot of current to want to overcome the stuckness that is there. Okay, so the provision of the interlocks which should also be mechanical or electrical, of which an interlock, we are going to make discussion and give an examples of electrical interlocks. All right, the ability to isolate the power from that is ability to isolate the motor from power in an event when there's a fault. But also ability to control the speed, like I had made mention. Also the ability for motor braking, because we understand that at the end of the day, the motor also needs to stop. So as it stops, you need to have that mechanism as well. And most importantly, you do not expect your motor to only be moving in one direction, but in both directions. And so the ability for motor reversal. And so to understand the first concept of design, there are certain pilot control devices that we need to understand. One, there's what we call the start push button. All right. So for the start push button, they are commonly used in motor control applications to start the motors. Okay, as well as on the issues of override process functions. Okay, and so for the start push button, this is the symbol. So the numbers are 3 and 4. This is for start. Then we equally have a stop which is 1 and 2. So for this, for the stop, this is a stop, which is 1 and 2. So for the start, this is normally open, and for the stop, this is normally closed. The difference is that for the normally open, it means that in its normal state, the contacts between 3 and 4 are always open. How so? If we are going to use a multimeter on continuity test, you'd find that if you check between 3 and 4, there's no continuity. But in an event where you press this push button, you check between 3 and 4, it will give you continuity. But for the stop push button, since it is normally closed, if you check for continuity between 1 and 2, it will give you. But if you push this push button down, it means 1 and 2 won't give you continuity because you would have broken that contact. Alright, then the other component is an MCB, which is miniature circuit breaker, which is just a breaker in many people's perceptions, that they just call it a breaker, but it's a miniature circuit breaker, of which it helps us be able to break contact between 2 points automatically or manually, of which in an automation, in case there is a fault, and so the breaker is simply just going to trip. Okay, then the other one is a contactor. Okay, so a contactor is just a mechanical switching device that is capable of making, carrying, and breaking electric current under normal conditions, including operating an overload condition, through an overload, that is. Yeah, and basically contactors are designed according to the method of energizing circuit, which can either be electromagnetic, pneumatic, and also electropneumatic. And so this is a symbol for the contactor, of which the contactors A1 and A2. So for contactors 24 volts, 110 volts, okay, that is 24 and 110 volts, 220 volts. These use live and neutral. So meaning on the A1 you put your live and your A2 you put your neutral. But for contactors that are 380 volts, it means on A1 if you put your red phase, here on A2 you can put yellow or blue, because the coil demand for it to energize is 380 volts. Okay, then the other one is an overload. So on overload, we have a normally closed part overload, and also normally open overload. So today what I want us to do is just basically do a simple design, because other components we introduce you as time goes on. So we have our MCB. From MCB we need to connect an overload because we need to intensify the protection of the motor. From there we go to the normally closed, which is the stop push button. From there then we introduce the start push button. From the start push button, then that's when we can connect our contact. So our overload, this is 95, 96, stop 1, 2, 3 and 4, A1 and A2, and we can name our contactor any letter that we desire. Okay, so the operation is that once we press the start push button, power is going to flow through the overload to the stop. Since these are all normally closed, once we press our start, then B is going to energize. If we let go of our start, B is going to de-energize. And so in order for us to continuously energize B, we just introduce a point called the hold on contact 13 and 14, so that if you press our start push button, the normally closed of B are going to be open and the normally open are going to be closed. So if these are going to be closed when this is energized, if you let go of our start, power is going to use this path and B will continuously be energized.